So we dealt with triangles. Now we're going to turn to quadrilaterals. Quadrilaterals if you can't read my handwriting, it's written right there, are closed figures with four sides and four angles. Now you may feel like I emphasize the words and what they mean a lot, but I know I teach math, but I do believe our language and the vocabulary really does matter. So quad means four. You may not know, but on college campuses there's often one area between buildings that's shaped like a rectangle. It's usually just a lot of grass, maybe some trees. It's often called the quad because it's a rectangle or something like it. Also, your muscles, in your arms, you have a bicep, which, if I'm remembering correctly, it's called a bicep because it has two connectors. One close to your elbow, one close to your shoulder. The tricep underneath it actually has three connectors. I admit I don't remember where the third connection is. And then our quadricep, that's the muscle on our thigh that's like on the front of our leg. It has four connectors. So quad means four, and lateral means sides. So this really just means four sides. So the segments that form the quadrilateral intersect only at their endpoints. So this means they can't have any curved lines, and their lines can't cross over each other. So just to make sure you understand why they use some of these words, closed figures. So if I drew this, for example, that has four sides, but that's open. There's an opening right here. I could get inside there if I was walking. We want a closed figure to be a quadrilateral. But also, we actually have to have them end at each other's sides. We can't have it where they do like something like this and they extend beyond. So that's not a quadrilateral either, because they don't end at the end points where they meet. But some common types of quadrilaterals are squares and rectangles, which I know you're familiar with those. Trapezoids look something like this. And rhombi, or rhombus is the singular, they look kind of like this. But we'll get into that later. But those are examples of quadrilaterals. And mainly I wanted to bring these two up so you know squares and rectangles have very particular shapes. Squares and rectangles are very similar because they've got four right angles. They're very rigid in the way they're formed. But there can be slants. There can't be curves. I can't draw, three sides and then a half circle to connect it. That's not a quadrilateral. But there can be slants, like there are here and here. This is actually related to triangles, quadrilaterals, because any quadrilateral, no matter how I draw it, any shape drawn with four sides can be divided into two triangles. You can see this one. It looks a little bit like a diamond maybe, but honestly it's just kind of a strange shape. If we draw a line from one of its points of intersection to the other, it then forms 1, 2 triangles. Now here's the reason I'm pointing this out. We know the sum of the angles in a triangle. That's 180 degrees. So if a quadrilateral can be viewed as two triangles, then the sum of its angles must be double that, which makes it 360 degrees. So the reason every quadrilateral, no matter what kind, and there's even kinds that aren't listed here, all quadrilaterals have a total of 360 degrees in their four angles, and it's because they are really just made up of two triangles, which we know have a total sum of 180 degrees each. So 180 plus 180 equals 360. So let's use that information about 360 on this first example. So find the value of x in the quadrilateral. Let's start there, but please note there's another instruction after that. But step 1, find the value of x. Well, we know these four sides, because this is a quadrilateral, said the wrong word, these four angles have to add up to 360 degrees. So I'll begin by saying x plus 7 plus x, so I covered that one, plus 75, And remember, this is a right angle. That means 90 degrees. All has to add up to 360 degrees. So one question you might be asking is, does it matter what order I list these terms in? No, not at all. As long as you list all four of these and add them all together, it doesn't matter where you start or stop. You just got to make sure you actually do include all four of them. So let's combine like terms over here. So I have an x here and an x here. 1x plus 1x is 2x. So I got that covered. Then 7 plus 75 plus 90 is 172. Sorry, wrote the wrong thing there. 360. So then I subtract 172 from both sides. That gives me 2x is equal to 188 degrees. And I'm fine with using a calculator on these. Then we divide both sides by 2, and we find out that x is equal to 94 degrees. So sorry if I went through that a little bit too quickly, but just to review what we did, we know all four angles have to add up to 360 degrees. So I took the measure of all four angles and added them together and set them equal to 360. I combine the like terms. The 2x's is 2x. 7, 75, and 90 adds up to 172. Then I subtracted 172 from both sides and got 2x equals 188. Then divided both sides by 2, so now I know what x is equal to. Sorry for all the coughing. So now it says find each missing angle measure. So we did do step 1. They said find the value of x. Step 2, we need to say, all right, if x is 94 degrees, well, this is 94 plus 7, which is 101 degrees. This one is equal to x, so it's 94 degrees. So after we find the value of x, they want us to plug them in to the angles that had x. So we knew, okay, this angle is 101, this angle is 94. Okay, now we're going to talk about those different sides. Quadrilaterals can be classified by their relationship of their sides and angles. So we learned how to name triangles like equilateral, equiangular, acute, obtuse, right, isosceles, scalene. We can also figure out how to name quadrilaterals based on things about their sides and their angles. So a rectangle, for example, this side and the side opposite that side have to be equal to each other, have to be congruent. This side and its opposite side also have to be congruent to each other. So that's one requirement for rectangles. They have two pairs of congruent sides. Another way to say it is their opposite sides are congruent. And as far as their angles, every one of their angles is a right angle. So a rectangle has 4 right angles. Or you could say 4 90-degree angles if you wanted to. Okay, and one thing I want to make clear, it is possible that all the sides are congruent, but that's not required. A rectangle is required to have its pairs of opposite sides be congruent. It's possible all 4 are congruent, but what's required is that this opposite set or opposite pair is congruent and this opposite pair is congruent. Now a square, it also has 4 right angles, and all 4 of its sides are congruent. So a square has 4 congruent sides and it has 4 right angles. Now maybe you've had teachers talk to you about this before. A square is a rectangle. If you look at the requirements for a rectangle, a square meets those. It has 4 right angles and its opposite sides are congruent. But a square is a particular type of rectangle. Because a square, not only are its opposite sides congruent, but all four sides are congruent to each other. A rectangle, that does not have to be true. It can be, but doesn't have to be. So every square is a rectangle, but not every rectangle is a square. Okay, these are trapezoids. These little arrows right here, and sometimes they'll be written just more like this instead of like with a little boxed in like that. But those arrows mean they're parallel. So trapezoids have exactly two parallel sides. In other words, only one pair can be parallel. If if these were parallel and these two are parallel, we're not trapezoids anymore. So a trapezoid has exactly two parallel sides. And all four angles are not congruent. Or maybe better to word it, none of the angles are congruent to each other. So you've got all four angles. It's not possible for any of them. I don't think that's true. Hold on. I think the better way to say it is there is no requirement for any of the angles to be congruent. Because as I'm thinking about it, there are ways that we have pairs of congruent. So really what this should say is no angles are required to be congruent. There we go. That's a better way to say it. Okay, this is a parallelogram. So see the difference between trapezoid and parallelogram. For it has to have two pairs of parallel sides. So its opposite sides are congruent and parallel. I think I could write the word and better than that. That's and, A-N-D. So for a parallelogram, its opposite sides are congruent and parallel. Sorry about that. Whoop. Also, in a parallelogram, opposite angles are congruent. So that angle is congruent to that angle, and this pair are also congruent to each other. Okay, a rhombus. Its sides are all congruent, so what makes it similar to a square is all four sides are congruent. I'm just going to write four congruent sides. And like a parallelogram, its opposite angles are congruent. And then the general term that applies to all of these is the quadrilateral. So I want to make sure you understand. A rectangle, it's a quadrilateral. A square, hey, that's a quadrilateral. Trapezoid, guess what? A quadrilateral. Same for the parallelogram and the rhombus. All four-sided shapes that are closed are quadrilaterals. Now, one thing you'll have to do on homework and on quizzes is label. Like I'll just show you a shape and say, what's the name of this shape, or how would you classify this shape? If it's one of these five, then you should put those names. Now, if it's a four-sided shape but doesn't fit the requirements for any of these, that's when you just write quadrilateral. So I'm going to just put any four-sided shape. And this name is used when it's not one of the other five. So I want to make sure I'm being clear here. Any four-sided shape can be called a quadrilateral. But if you see a square on a quiz and you just tell me it's quadrilateral, I'm not going to give you credit for that. Because since the quiz is on quadrilaterals, just telling me that's a quadrilateral is not really the point. You'll have to write that it's a square. But if it's a shape like this that doesn't have parallel sides, doesn't have congruent sides or congruent angles, none of the requirements we have for the others, then you would just say, well, it's not a special type, but it's a quadrilateral. So only use this name, quadrilateral, to describe a shape when it's not one of the special 5 types we've learned here.